Should you use GraphQL? Should you choose GraphQL over REST or other options in the application you're building? This video helps you to answer those questions for yourself and shows a little demo where using GraphQL actually makes an application better for the users. My name is Viktor Lukashov, and I work as an engineer on the StepZen team. Let's go. First, a very brief intro to GraphQL. So what is it? Well, GraphQL is a way to access data, is a protocol in a sort of sorts. A core assumption there is that you could represent all of the data you have as a single graph. And queries with GraphQL look a lot like JSON. So if you are familiar with JSON, you would be quickly familiar with GraphQL. It would be very easy for you to read and write those queries. It is fully typed. So all the queries at the type of writing the queries, you would have all the information about what types of data there is. And so you could get support and checking at that point in time. Typically, GraphQL is exposed over a single post endpoint in case if it's served over HTTP. It was published first to the world around 7 years ago by then Facebook, now called Meta. And if I can trust public sources on that, it was the development started 3 years before that, which makes a GraphQL about 10 years as a technology in 2022. Now, at this point, it's no longer governed or owned by Facebook or Meta. It is governed by something called GraphQL Foundation, with many companies in it actively contributing to this standard, because many companies actually use it and don't want a single one to control it. StepZen, the company I work for, is a part of the foundation, and we are part of those discussions that happen about how to develop the standard further. Now, this list is alphabetical, which makes StepZen closer to Twitter than to Amazon, but I believe we're still in a good company nevertheless. Query. With GraphQL, a query would look something like this. Very similar to JSON, but you quickly spot a difference. With GraphQL, you could add arguments to any field anywhere in the query. The response in GraphQL is always a JSON structure with a data property containing all the data that the query fetched, and possibly an errors property in case if there are any errors. Data could be null in that case. Now, since GraphQL is fully typed and you have a schema that describes the structure of your data, you have wonderful support from development tooling. At the time when you author your query, you can get auto-completion, you can get checking that you're not making any typos, you can get documentation at the right time. Well, that's all becomes possible because there is a schema, and this is essentially the cost somebody needs to pay for the convenience. In a typical example that's used by many GraphQL demos, the data graph describing Star Wars starships is a simple example, but yet even in that case, the schema is 1,168 lines long, and somebody actually had to spend the time to write and maintain it. So it's not for free. Now, comparing GraphQL to the most obvious alternative, which would be REST, I've come up with a list of points here just to give you a taste of what is similar and what is different. First, if you know REST, you know that there is a lot of discussion going on. Should you use get or post or put or delete or which other HTTP verb, and how to create and structure your endpoints and how to map them to HTTP. They are HTTP endpoints. That is not the case in GraphQL. In GraphQL, typically, if it's exposed over HTTP, it is a single post endpoint, single entry point. Now, that means when you make a query, when you fetch some data using GraphQL, you would make a single network call per query. Whereas if you use REST, you would make as many network calls, as many calls you make, and typically with REST, you have as many REST endpoints as many there are entities that you need. And if your view needs many of them, you'll make many calls. The structure of the response with REST is always defined by the developer of the REST API, and it is fixed, typically. Every single client would get the same structure of response from the same endpoint. With GraphQL, there is one endpoint, but the response would be different because every request is very explicit. Every request contains the exact description of what data, of what subgraph of data you want to get. And it is unique per request. Then, when it comes to access control, with REST, there is an established pattern. Typically, you'd have access controls defined on every single REST endpoint with HTTP authorization headers, and you can describe which endpoint would require which permissions from user. With GraphQL, there is no standard way of doing that, and so every implementation would come up with its own ways to define access controls. And typically, it's not on that single HTTP endpoint. It is more fine-grained. It is typically on different types or different sub-graphs of the data graph. Schema, yes, I mentioned with REST, you could create a schema using something called OpenAPI, or used to be called Swagger. But it's up to you. Do you want to create it or not? And it's also up to you to keep it in sync with the actual implementation. With GraphQL, this is not an option. It's a mandatory part, and it is always in sync with the implementation. Support for real-time data is something that GraphQL has out of the box. There is first-class support for the concept called subscription, where you as a client of a GraphQL API could define a subset of your data that you care about, and then server would detect changes. Whenever server detects changes to that subset of data, of data graph, it would push updates to your GraphQL client, supporting real-time data updates. With REST, it is much more complicated to build something like that. Of course, there are ways to do it, and you could create long polling, or you could just poll in a loop, but there is no support for you from REST as the protocol there. And all that boils down to, in my opinion, when you build a GraphQL API, your server-side code, the implementation of that API, would tend to be more complex than comparing to building a REST API. And that's because GraphQL has more features that you as an API developer would need to think about. And of course, there are libraries to help you with that, but still, even with using libraries, there are more corner cases that an API developer would need to consider. With REST, it is a little bit more simple, and maybe just because there is also just more people who have built any number of REST APIs and who had this experience from before. Yeah, it's kind of once you build one REST API, then you know how to build others. With GraphQL, it might be not so obvious. Now, knowing all that, how GraphQL is different from REST and how it's similar to REST, when should you use which? So I would say use REST if the application that you're building, for instance, a web application, where the views of that application map one-to-one to the REST endpoints. And that could typically be the case when you're building some sort of CRUD user interfaces, could be admin panels of some sort. And there, every single view of the application is basically backed by one or two REST endpoints, and it all works very, very well. So you don't need anything more complex than REST there. Use REST. Also, another reason, use REST if it's the same team that works both on the backend and on the front end, because then it's very easy for that one team to know what is the exact shape of the API, what is the exact shape of the response that their client side needs from the server side. And of course, they would build it in that way that they need. And yeah, there is no reason to complicate things by introducing something more complex than REST. Another reason where REST could be a good choice, another situation, is when the number of data sources is many, and they are different, heterogeneous data sources provided by different teams or maybe even organizations, and there is no team or budget that you have on your disposal to build something on top of it. REST could be the common language, the lowest common denominator that is equally well understood everywhere. And if you don't have a team to make anything better than that, then yes, use REST. It's better than using different API protocols or approaches per data source. Now, coming to when to use GraphQL. It's sort of the opposite from above, but not exactly. So use GraphQL if the data requirements are complex or if they are varying from view to view to view, and you might need to have just a little subset of user data on one view, for instance, just first name, last name, and different subset on the other view, and yet another different subset of the same data on third view. And so it becomes a problem if your user API always responds to you with the same structure. You would be overfetching in most cases, so you will have to send more data over the wire, or you will end up multiplying the number of those REST endpoints, each of them returning user data, but in slightly different varieties. So if that's the situation you are in, consider GraphQL, because there every view would define its own requirements to the data, and you would avoid overfetching. Another reason to use GraphQL is if your organization is structured in a way that the backend team and the frontend team, they are separate, and they might work or belong even to different organizations. They might work at different cadence. They might have different backlogs, different priorities. And if this communication between the teams is not very smooth, using GraphQL helps to uncouple this dependency, because the client-side teams would have more control over what data they get. Now, another reason to use GraphQL is if you actually need the benefits it gives. If you want to, for instance, you are in the cases 1 and 2 mentioned before, and you also have either an in-house team that knows how to build a GraphQL API layer on top of different data sources, or if you have budget to externalize that and purchase as a service, somebody would build that GraphQL layer on top of your data sources for you. That's a good reason when you can and should use GraphQL. Another reason is real-time data. With REST, it would be more difficult. With GraphQL, it is easier. So if you have that requirement, GraphQL is a good candidate. Typing. If you are in a situation where you want to rely on strongly typed languages, if you want to rely on tooling to make sure that you're not making mistakes or typos, GraphQL is a better choice for you than REST, because typing and type checking is built in there. Now, let's switch to a little demo application that I built to demonstrate a use case where using a GraphQL API instead of REST would actually make your application better for the users. And by saying better, I mean it would load quicker. Now, this is a completely made-up example of a social network, or rather a notification feed over a social network. It shows a list of notifications like so-and-so reacted to your post with a reaction, thumbs up, and a short summary of the post, and then the name of the channel it was posted in. And there is a list of those, including the user avatars. Now, all of that data comes from a single endpoint, /notifications endpoint. This is an API I made for the example. It has this endpoint /notifications, and it is looking like REST, but it's not the typical REST endpoint in the sense that it is highly denormalized. It includes more information than just notification. It also includes information on users, on the posts on the channel, and so on. So it provides a lot of data at once and enough to render that view. All good. Users are happy because this page loads very quickly. You have very much tailored API for that, for your case. What now? Suppose somebody from the product team comes to you and says, hey, we want a hypothesis. We want to test a hypothesis. What if we add a country flag next to the username here and see if that improves the engagement? And they've already done their homework because they went to the backend team and they checked if the country information is available for users, and sure enough, it is. The problem, though, is when you look at the API that you're using to render a page, you see that given by user information does not include the country. Yes, there is a different API endpoint in addition to /notifications. See that /notifications is here. And then there is a /users. Well, you know that because you worked in the company for a while. You know the APIs that exist, users and then user ID. And there you'll see country information, but it's not in the endpoint that you're using to render the list of notifications. So yes, the data is there, but you don't have access to it yet. What could you do? Well, one way is you go to the team maintaining the /notifications endpoint. And if it is your own team, then it's very easy. You add the additional property, and then you're good to go. But if it's a different team, then it might take a while. What you hear back might be that come in a few sprints. And then you have to wait for a month, or you have to use a less performance solution, which would be, let's look at the code. The initial version of the code rendering this page and fetching the data notification data is simply calling the /notifications endpoint with the browser default fetch API, getting the data, sending it to render the page. It's very easy, but it doesn't have flag information. Now, you could create another implementation that would combine the two endpoints, and instead of just calling the /notifications, would also then call the /users endpoints for every single notifications to add that country information in. And let's see if that's going to work. Switching back to the application, you see the flags there. So yes, it does work. But soon enough, the product team comes back to you and says, you know what? Now we didn't only add a flag here, but you also made this page load much longer because, now every single user data would be fetched to render this flag. And that makes the page load times longer. Some people are unhappy, and engagement metrics have not increased, they actually decreased. And that's not because of the flag, it's because of the page load times. Can you do better? Yes, you can. One, you can wait for the backend team to change the /notifications endpoint to get all the data at once. Or two, if you had a GraphQL API to access the data, then you don't need to wait for a backend team to add this field. If it's already in the graph, you can just get it. But if you don't have a GraphQL API to start with, then it's kind of hard. Now, what StepZen does for you is allows you to take an existing endpoint, REST API, and create a GraphQL API layer on top of it. And would be doing that using something called StepZen API. StepZen CLI, command line tool, StepZen. And if you have a REST endpoint such as one you can curl, say notifications or users, you could use StepZen import command and pass it the curl, so that StepZen would go reach out to this endpoint, introspect the response, create GraphQL schema for it for you, and then you can deploy it using StepZen start. It's going to be deployed to StepZen servers. Now this is what's happening, and here is the GraphQL API URL for you to access exactly the same data that is available here. And this is the local graphical that you can use to check it out and see how that works. I'm going to give it a try and see notifications reaction given by first name, last name, and avatar, and just run this and see if that is still giving me the same data. And yeah, looks pretty much it. Still doesn't have the country information, but just stay with me and we'll see how we can get it there. Let's just have a brief look at the schema that was generated for you from this endpoint. So what StepZen import command did, it created this file, completely automatically generated, created some types, and created one query field. The default names are not very intuitive, so I'm going to give it a little tidy up, but that's also possible by giving additional parameters to the CLI import command. I'm going to call this notification list, and instead of saying this is a root, it's a notification list, and then instead of entry, it's a notification. Now, there are also some duplicates that I'm going to remove here. Instead of author and given by, I'm going to use just the user type, because that's essentially all users. And this is now a little bit cleaner. Let's see if that still works. It's automatically deployed, so I've refreshed this. I check if it's reaction given by first name, last name, notification list, no user, old query, run. Yes, still there. Now, how to get the country information in? I'm gonna, instead of typing this, I have already prepared a little additional thing that I'm gonna copy into my index.graphql file. And what I'm gonna do here is I'm gonna add additional query fields, again, backed by my REST API, but this time a different one, a /users API. Now, this is a second query. One was notification list. This query is user query, user country. And then I'm going to extend the existing type, add additional field to it, and say that whenever this type is being returned by my API, it should get this property of the user object from this query. I'm saving it and see if that deployment is in progress, is deployed. Now, if I go here, I refresh this, I see countries there, I run, and I see that now not only I have the user information, but also the country information. So country is now part of my GraphQL data graph, and I can use it in my application here. Switching from the REST implementation to GraphQL implementation, seeing that now it queries my GraphQL endpoint deployed to StepZen, and it explicitly lists all the properties it wants to get, including the country. Switching to the application, I see that the country flags are there. And now, looking at the network, I see that the single call to the GraphQL API, that includes all the data I need to render this page. So the page load time is back to where it was. Actual amount of data transferred is even less than it was before, because I'm explicitly asking for the properties, only for the properties I need. And now my product team is happy. They are validating their hypothesis because nothing else has changed except for now there is a flag here. The page load times remain the same. Number of network calls remain the same. The data still comes from the same API, but the GraphQL layer hosted by StepZen does the fetching and caching. Now, switching back to slides here, demo time is over. OK, to summarize, GraphQL is a way to access your data similar to how you can use REST to access your data. Implementing a GraphQL backend might be a bit more complex, but the amount of features you get is more than you get with REST. In some cases, it is worthwhile investing into that complexity because the features you get out of GraphQL would make your application better for your users. You could build a GraphQL API layer yourself, or you could use a service like StepZen that creates and hosts this GraphQL API layer on top of the existing data sources you have, be it REST, SQL, NoSQL database, or another GraphQL endpoint. Thanks for listening. All the illustrations in this video were generated by the DALL-E 2 neural network. Thank you.